Please open in your learning workbook to page 110 as we solve several problems involving adding and subtracting radicals. Here's the first one. Find the perimeter of the trapezoid, give an exact answer using radicals as needed, include correct units in your answer. Okay, I've sort of written the shortened version of the instructions here. Find the perimeter of the trapezoid, exact, meaning we want an exact answer, and all lengths are in inches. All right, so what does perimeter mean? Perimeter means to add up all the lengths of the sides. So we travel around the trapezoid, adding up lengths of sides as we go. We'll start at the top. 2 square root of 24 plus square root of 24 plus 3 square root of 6 plus 5 square root of 54. Okay, we'd like to add all of these things together, but remember, you can only add like radicals. These are the only two like radicals, as of this moment, the way these are written, that we have in our problem. And the coefficient of this radical right here is a hidden 1. So this is 2 root 24 plus 1 root 24. So we can combine those just like we were combining things in algebra. If I said, hey students, what's 2x plus x? You would say that's the same thing as 2x plus 1x, which is 3x. The same thing is true for radicals. 2 radical, and I'll use the number 24 here, plus radical 24 is the same thing as 2 radical 24 plus 1 radical 24, which is 3 radical 24. Just like the variable does not change when you combine likes, the same thing can be said of radicals. The radical does not change when you combine like radicals. So 2 root 24 plus 1 root 24 is 3 root 24. And then of course I still have the rest of the problem. Plus 3 root 6 plus 5 root 54. Now, am I done with this problem? Is that as far as I can go? The answer is no. And the reason why is because these may yet still be like radicals. As we learned in our previous video, we have to simplify radicals first before we can determine if they're like. So let's simplify these radicals. Here we go. All right, we know that 24 is 3 times 8. And we know that 8 is 2 times 2 times 2. So this is another way of writing 3 root 24. Okay, let's continue on. 6 is the same thing as 2 times 3. And finally, in our last one, 54, let's make a tree for this one. This one's a little bit deeper than the other two. I think a visual is going to be helpful. 54, well, that's the same thing as 6 times 9. 2 times 3 makes the 6, and 3 times 3 makes the 9. So we get 5 square root of 2 times 3 times 3 times 3. Now these are all square roots. The index is 2. So we're looking for pairs here so that we can simplify. So there's a pair, which will come out to multiply. There are no pairs here. There's a pair here, which will come out to multiply. So our next line will look like this. We have the 3 that we had out from the beginning, times this 2, which is coming outside, times the square root of 3 times 2, plus 3 times the square root of 2 times 3, plus the 5 that we had outside, times the 3 that came to join it, times the square root of 2 times 3. Okay, now we're going to put things together. 3 times 2, 6 square root of 6, plus 3 square root of 6, plus 15 square root of 6. Notice they all have the same radical. So these are like radicals after all, and therefore they can be combined. So add the coefficients. 6 plus 3 is 9, plus 15 is 24. So we get 24 times the square root of 6 inches. This is the exact correct answer with our units of measurement. Okay, let's try another one. Okay, in this problem, we're asked to add or subtract as appropriate. And we have the following. the cube root of 54xy cubed minus 8 times the cube root of 2xy cubed plus y times the cube root of 16x. Okay, well, upon first inspection, we would lead to the conclusion that these are all unlike radicals because the radicands are dramatically different. They all have the same index of 3, but the radicands are completely different. Yet, it may still be the case that these are like radicals. We just need to simplify to discover whether that's true. Okay, so let's go ahead and make our trees here. So we did 54 in the previous problem. We found that 54 was 2 times 3 times 3 times 3. And then the xy cubed will be an x times a y times a y times a y. Continuing, minus 8 cube root of 2x y y y plus y cube root of, now 16 is 4 times 4, and each one of those 4s gets written as a 2 times 2. So we have 2 times 2 times 2 times 2, that's 16, times x. These are cube roots, so we don't want groups of 2, we want groups of 3. So here's a group of 3, here's a group of 3, here's a group of 3, here's a group of 3. Each group sends one representative out to multiply. So now, outside here, I have a 3 times a y, and inside I have a cube root of 2 times an x, minus 8, the y comes out, so 8 times a y, times the cube root of what stays inside, 2 times x, plus 3 times the 2 that comes out, times the cube root of 2 times x. Turns out these are like radicals after all. They are all the cube root of 2x. All right, so let's put this together. We get 3y times the cube root of 2x minus 8y times the cube root of 2x plus 6. Yep, there should have been a y. You all probably noticed that mistake a long time ago. Sorry for the error. Plus 2y times the cube root of 2x. Okay, now we just have to combine our like radicals. Remember, the radical part does not change when you combine like radicals. You simply add the outside pieces. So 3y minus 8y plus 2y. Let's work that out. 3y minus 8y is negative 5y, plus 2y makes negative 3y, and all of that will be times the cube root of 2x. Okay, there's our final answer. Let's do one more problem. Add. Assume that all variables represent positive real numbers. Well, our only variable is x, so I'm just going to write x is greater than 0 and x is real. And we have 63 over x to the 8th power, all under our square root, plus 7 over 4x to the 8th power, all under a square root. Okay, let's work on simplifying this. So the first skill we're going to need here is the quotient rule for radicals, which says that a radical of a fraction can become two radicals, where the numerator gets its own radical and the denominator gets its own radical. We'll do this to both of our fractions. Okay, the second step that we're going to follow here is to simplify each one of these radicals. For example, the square root of 63. 63 is the same thing as 7 times 9. 9 is 3 times 3. So we can rewrite this numerator radical as 3 times 3 times 7, all under that square root. The denominator is just 8x's. Okay, the square root of 7 cannot be rewritten. 7 is a prime number. There's nothing we can do to change it. But 4x to the 8th, well, 4 is 2 times 2. So I have 2 times 2, and then 8x's. All right, these are all square roots. I'm looking to make groups of 2. So here's a group of 2. There's 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 a group of 2. Group, 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 group. Each group sends one representative out to multiply. So now what I'm going to have is this. 1 3 comes out. The 7 stays behind. An x, an x, an x, an x comes out. That's x to the 4th. Plus square root of 7 over a 2, an x, an x, an x, an x comes out. So that's 2x to the 4th. Okay. Now this is not my final answer because I want to combine my two fractions into one. I'm going to use the jealous method here. When I compare these two denominators, they are almost the same, except that this one has a 2 that this one is jealous of. So I'm going to multiply times 2 top and bottom. This will give me 6 square root of 7 over 2x to the 4th plus square root of 7 over 2x to the 4th. And now that my denominators are the same, I can combine my two fractions into one. Remember, the denominator tells you the type of thing you have. So when you add or subtract when you add or subtract fractions, the denominators do not change. So this is going to be 2x to the 4th. And we have to figure out how to add these together. Well, they're like radicals, and the coefficient of the second one is a 1. So 6 root 7 plus 1 root 7 makes 7 root 7. Our final answer is 7 root 7 over 2x to the 4th.